of x is the function x plus 4. And then they give us a bunch of coordinate points where they only give us one of the two values in the coordinate point. If you look at the coordinate points that are given there, did they give us the x or the y value? The x, okay? So what could I do to find the y value? Yeah, just plug it into the equation. Perfect. So if we plug in 1, what are we going to get for a y value? 5. What about 2? And 8. Perfect. Okay. So if they are giving you some x value and you need to find y, just plug it in. If they give you y, you would plug y in right here and then solve for x, right? Okay. So they go on to say that the inverse of a function, so the inverse of f of x here, would be denoted using this f with almost looks like an exponent of -1. And this is found by interchanging the first and second coordinates from your function. So in other words, you switch the x and the y values, and that would be your inverse. Okay, so the inverse of these points would be 5, 1, 6, 2, 7, 3, and 8, 4. Well, if I switch all of the x's with all of the y's, then what would my domain technically be now? Domain is my x's or my y's? X, okay. And we just switched the x's and y's. So I switched my domain with the range. So the domain in your inverse is actually going to be your range. That means the range becomes the domain, right? So that makes sense. If we switch all the x's with all the y's, the old x's or the old domain is my new range and vice versa, okay? They go on to say that f and f's inverse are basically undoing each other. So they should kind of cancel each other out in a way. So if you were going to actually solve an equation, they should undo one another. So, for example, they gave us the original function up here, f of x is equal to x plus 4. We said we were going to switch all the x and y coordinates, which basically means the domain and range switch, which should mean anywhere there is an x, it switches with a y, including in the equation. So, f of x, remember, is the same thing as y, right? If you wanted to tell me what the inverse equation was, instead of just telling me what the new coordinate points would be, you would need to switch your x and your y. So in the equation, if I switch x and y, I would now have x is equal to y plus 4, right? Okay, so this would be the inverse function. However, we don't typically like to see our equation as x equals. We like to see it as y equals, right? So I would want to solve the equation for y, get y by itself so that it's in the correct form. So what would I do to get the y by itself here? Subtract 4. So I'd have x minus 4 equals y. And remember, we denote it with this little inverse, so you would see it written as the inverse is x minus 4. All right? Like we were just saying, they're basically opposites of one another because we switch the x and the y, so they have a way of undoing one another. So if you need to prove or verify that something is a function and its inverse function, it says all you would need to do is a composite, which is what we've been practicing the last couple days. It says you would need to plug the inverse into the original, and you should just get x because everything's going to undo one another. You also would need to plug the original function into the inverse, and again, you should just get x because they should undo each other. So that's how we're going to verify whether or not it's an inverse or not, okay? So example 1 says to find the inverse of the equation f of x equals 8x, and then verify verify, it says we need to do it in this way, that they are equal to the identity function. The identity function is what we had here and here. So this is the identity function. It's just x. Okay, so first thing I need to do is just find the inverse function. Well, we just did that up here. What did we do to come up with this new equation up here?
Subtracted 4.
Before that.
Switch the y's and x's.
Very good. So that's exactly what I need to do here. Remember, this is like a y. So I'm going to switch the places of the x and the y. So my inverse is going to be x equals 8y. But again, we like y to be by itself. So now I just solved the equation for y. And how would I do that? Divide by 8. So we end up with y equals x over 8, or also sometimes written, like we said, with that little denotation of inverse in this way. So our inverse function is x over 8. Okay, it says we need to verify that this is in fact the inverse by performing these two compositions. So the first composition says take the inverse, plug it into the original. So here's my inverse. I'm going to go plug it in to the original up here. So I would have y, or f of x, whichever way you want to write it, is equal to 8 times, what am I replacing the x with? X over 8. And what's that going to simplify to? X, right? Because those 8's divide out, we are just left with x. Okay, so the first one did give us the identity function, so we're off to a good start. Now I just need to do it the other way around. So now I'm going to take the original from up here, sub it into the inverse function. So now I'm going to have my inverse is equal to, I'll have, instead of x in the top, I'll plug in 8x over 8. Well, again, what's going to happen? Right. So we did, in fact, get x, the identity function, both times. So we did verify that these are inverses of one another. All right? Okay, so I want you guys to do number 2. I want you to come up with the inverse function of 7x plus 4. It says it should be one of these two options down here. Once you figure out which one it is, then I want you to verify it. So just plug it in like we did here. All right? So I'll give you a second to try number 2 on your own, and then we'll go over it. All right, so on number 2, that f of x equals 7x plus 4. How did you guys find the inverse? What was your first step to find that inverse equation? Right, so now I'm going to have x equals 7y plus 4. And then where'd we go from there? Subtract 4. And then what do we do? Okay, so I got x minus 4 equals 7y, and then I divide by 7. Perfect. So this is what we're left with. This is our inverse function. So was it g of x or h of x? G of x. Okay, perfect. And then how do I verify?
Do the inverse first.
Right, plug one into the other, right? So let's plug the inverse into the original first. So that would look like 7 times, instead of x minus 4 over 7 plus 4, right? Order of operations says we would multiply first. What happens when I multiply by 7?
Cancel out. 7 on the bottom.
Right, perfect. So then I'm just left with x minus 4 plus 4. And the negative 4 and the positive 4 cancel each other out as well, right? Okay, so it worked that way. Now I'm going to go the other direction. So I'll have 7x plus 4 minus 4 over 7. Well, again, these are going to cross out, right? And then these cross out. So it did, in fact, give us the identity function both ways. So we have verified that is, in fact, the inverse function. Okay, so now we know how to find the inverse function and verify. Now we're going to talk about graphing our inverses. It says here that if you have some point AB on your graph of the original function f, then the point BA is going to lie on the graph of the inverse function. Well, that makes sense, right? Because we said every x switches with every y. So it basically flip-flops the coordinate point. It says the graph of the inverse is going to be a reflection over the line y equals x. Well, what does the line y equals x look like?
Straight line.
Diagonal line, right? It goes through the origin, 0, 0, and it has a slope of 1. Okay, so it says we're going to sketch both the original and the inverse function right here, and we're going to see, does it look like it does, in fact, reflect over the line y equals x? Okay, so let's see. We'll start with the original function, 4x minus 1. Well, that minus 1, that's my y-intercept, right? So that tells me I plot my first point here at negative 1. And then my slope tells me I'm going to do what? Good. Okay, so here is our original function, f of x. Okay, now I want to graph the inverse function. Well, here's my inverse function right here. Not like we typically see it, right? Not written in the same way that we liked that first equation to be written. But remember, I can split those up. So I could also say that the inverse function is x over 4 plus 1 over 4, right? And then it looks a little more like what we're used to seeing. We know there's an understood 1 here in front. So this is really 1/4 x plus 1/4 or 0.25, however you prefer to think of it. Okay? So now, y-intercept, 0.25. And then my slope tells me to rise, and then we'll go right 4. Okay. All right, so here is my inverse function. All right, like you guys said, the line y equals x goes through the origin, and it goes up 1 and over 1. So here is my line y equals x here in purple. And we're just stating or deciding whether or not we think it looks like the black line was reflected or has symmetry over the purple line with the blue. Does that look like that? Yeah. Everything in black is equidistant from the purple line, just like the blue is, right? Okay, and then for example, we had a coordinate point right here at 1, 3. right? Okay, I'm not perfect, but I did get pretty close to that. Looks like I do have a point right here at 3, 1, right? And that's exactly what we said should be happening. All of the x's and y values are going to switch. Okay, so it looks like we did in fact verify. It will reflect over the line y equals x. Okay, flip it over onto the back, and it's the exact same thing. They give you the original function, and they give you the in the inverse function. They want you to graph them on here. And then they want you to see if you think that those are a reflection over the line y equals x. So I'm going to give you a second. If you want to look at your parent function notes because you've kind of forgotten exactly what points this one is going to give you, then feel free to look at your parent function notes. Those were your 4.5 notes. So I'll give you just a second. I want you to draw me a sketch of both f of x and the inverse.
Teachers and students, pardon the interruption. Students, we are noticing a trend with you not wearing your badges. This is very important for security reasons, and that's a requirement to be on campus, that you have your student ID visible on your person. Please do not keep them in your pockets. You have to have them visible at all times. Teachers, before students walk into your room, please check them at the door and make sure that they have their ID. At this time, if you have a student that does not have their ID, please send them to the closest office with Ms. Pope or Ms. Metter. The closest that can give an ID, Ms. Pope or Ms. Metter. Also, students, we have a large list of fines that still need to be paid. Please know that you will not be exempt if you owe fines. So if you know that you owe a fine, please see Ms. Pope ASAP and get that taken care of. If it does not get taken care of, again, you will not be on the exemption list. You will not be eligible to be exempt. You will also start getting discipline from your AP. Let's clean this up, guys, and take care of it. As always, if you have any questions, please reach out. Thanks, everyone.
Everybody got their badge? Yeah. If you don't have one, make sure you go get one from Ms. Pope. Okay, so let's take a look at these graphs here. So it says the parent function is x squared plus 1, which you guys know that the quadratic parent function looks like this, right? Okay, but it did give a restriction. It says we only want the part of the graph where x is greater than or equal to 0. So let's keep that in mind as we graph, okay? So parent function normally goes through the origin, but this graph says we should shift it where? What does this say? Shifts up 1. So instead of starting at 0, 0, it's going to start at 0, 1. Okay? And then we know we've got a point up 1 and over 1 from that spot. Also, if you go back to the origin, you got another one, 2, up 4, and you can add as many as will fit or as much as it takes for you to know what the function looks like. Okay, we know that there are points that mirror that over here, right, to make that parabola-like shape, but they said that they only wanted the part where x was greater than or equal to 0. Well, where is x greater than or equal to 0 on the graph? On the right side. So in other words, I want to not consider this part over here, right? Okay. So now that we've got the first one graphed, that next one we know looks something like this. Normally starts at the origin, but they said it was shifted where? Right 1. So I'm going to have my first point here. I normally have another point, right 1 and up 1, and then another point, up 1 more and 3 away. So however many points it takes for you to get a good idea of what that's going to look like. Okay, and then if I did go and graph that line y equals x, what do you guys think? Does it look like it has symmetry over that line y equals x? Yeah. Okay. What if I had not been told to restrict the function and gotten rid of that part that I marked out over there in red? Would at every point from the original graph have a matching point on the blue graph? No. So that's why they had to have us restrict it, right? Because it wouldn't work. So that's what we're going to talk about next. We're going to talk about one-to-one functions. So you guys have done vertical line tests a lot, right? That's what tells you whether or not something is a function. When you do a vertical line test, what are you checking for?
Is it a function?
Yeah, if it's a function or not. What's not allowed to repeat for it to be a function?
X values.
Right. So when I do a vertical line test, I'm checking to see, do any of my x values repeat, right? Because they'll be stacked under my pen or my pencil. Okay? It says for something to have an inverse, not only does it have to pass the vertical line test, it has to pass the horizontal line test. Because like we said, whenever we flip and get our inverse, the x's and y's switch, right? So I need no y's to repeat because those are going to be my x's when I switch them, right? So if I would have done a horizontal line test up here, would it have passed if I hadn't marked out that part in red?
No.
So that's why they had to have us restrict it. Because if we didn't restrict it, it wouldn't be an inverse because it would not pass the horizontal line test. Okay? So, keeping that in mind, it wants us to graph the original function here, which is going to be 3 minus x, and see if it passes the horizontal line test. If we say yes, then we need to give the inverse. Okay? So, again, feel free to split these up if you like to see it written in this way. Again, normally these are flip-flopped, so you might want to rewrite them in that way as well. 3 over 2 is the same as 1.5, so if you prefer it as 1.5, that works too. But this is going to be our original f of x function. So I'm going to come over here and graph it so I can see if it would pass vertical and horizontal line tests. So it's going to start at 1.5, and then our slope tells us to, it is negative. Very good. So here is our function f of x. What do you guys think? Is it going to pass both the vertical and horizontal line tests? Yeah. So vertical line test, horizontal line test, checks both boxes. So that means that yes, it should have an inverse, right? So we are saying yes, it's going to have an inverse. How would we find the inverse? What would we do on the front page to find the inverse equation? Very good. Switch the x and the y. So this is like my y. I'm going to switch their places. So I'm going to have x is equal to 3 minus y over 2, right? Okay. How would I solve for y? You got to get rid of that fraction, right? Okay. So I'm going to multiply both sides by 2. That's going to make those divide out over here. So now I've got 2x equals 3 minus y. Then what? Subtract the 3, okay. So now I've got 2x minus 3 equals negative y. Right, we want to get rid of that negative. So basically change all of our signs, right? So this will become positive and positive. This will become negative. So our inverse function is going to be negative 2x plus 3. Okay. And these would be equidistant across our line, y equals x. All right? Okay. All right, I want you guys to try the examples at the bottom, A, B, and C. So you're going to do the same thing that we just did on this one. Graph it, see if it passes the test. If it passes the test, tell me what the inverse would be. If it doesn't pass the test, then you don't need to give me an equation. You can just say no. Don't worry too much about graphing the inverse. If you'll just give me the equation, you'll be good. All right, let's take a look at these examples. So first function, x cubed plus 1. What is that graph going to look like? And it's been shifted how? So normally starts at the origin, but now we're saying shift all those points that we know of up 1. So our point that normally would be at 0, 0 is now at 0, 1. We know there's normally a point right 1 and up 1. So I can go right 1 and up 1 from that point I just plotted. And we also know that there's usually one down 1 and left 1. So there's always a point here as well, right? So our parent function x cubed but shifted 1 up is going to look something like this, right? Okay, so now that I have it drawn, we just needed to state whether we think it's 1 to 1. So remember, we check vertical and horizontal line tests. What do you guys think? Is it going to pass? Yeah, it's going to pass both. Okay, so we are saying, yes, we do think that it can have an inverse. So I'm going to figure out what the inverse function would be. How do I find the inverse? Switch x and y. So I'm going to have x is equal to y cubed plus 1. All right. And then how would I solve that equation for y? Subtract 1. Very good. So I'm going to have x minus 1 equals y cubed. Then how do we get rid of that cube? Cube root. So I'm going to take the cubed root of both sides. All right, so our inverse function would be the cubed root of x minus 1. And that's not a function you're supposed to know what it looks like, so don't worry about graphing the inverse, but we did find it. Okay. For part B, this is our quadratic parent function, right? What's been transformed about this equation, or what changes have been made? Down 2. So instead of starting at 0, 0, I'm going to start at negative 2. Okay? And then we know we normally have 1 point up 1 and right 1, and 1 point left 1 and up 1, right? And then a second point if you wanted to add them in either direction here and here. All right, so looks something like this. So what do we think? Is it going to pass the vertical and horizontal line tests? It passes the vertical, but doesn't pass the horizontal, which is the important part, right? Because those are going to be the ones that switch. So we would say that this one does not have an inverse. Okay? What about part C? What's the only difference between part B and part C? So what does that mean? Right, we're not going to plot any of the points on the left side. So basically, we only want positive x values. Okay, so still going to have this point here at 0, right? 0, negative 2, and a point right 1 and up 1. So I'll have this part of my graph, right? So what do you guys think about that one? Is that one going to pass? Yeah, this will pass both the vertical and the horizontal line test, right? Okay, so we're saying yes to this one. So that means I need to find the inverse function. How do I do that? Right, so switch these places here. So I'm going to have x is equal to y squared minus 2. Then what should we do? Add the 2, okay. So then I'm going to have x plus 2 equals y squared. Take the square root. Perfect. So our inverse function here is going to be the square root of x plus 2. All right.